Alright, so if you're using this video, the idea would be for you to try and solve the problem. This could be repeat, but my thing paused. If you're using the video, the idea is for you to pause it before I do it so that you can try it and then go from there. I'm going to be using the same strategy every time. I'm going to be doing the changing it to the common denominators. The only time you have to do that is here for 2. If you have other ways to solve the problem, please do. But that's what I'm going to do. All right. So if I have 1/6 plus 2/4, I look at those denominators, they're not the same. So then I start thinking about what do they have in common. So I have 4, 8, 12. And I'm going to start with 12 because I do know that I can just go with 6 and 12. So that means I'm going to have to take 1/6, turn it into something over 12, and I'm going to take 1/4 and turn it into something over 12. Okay, so I can rewrite all of that as, man, I kind of need more room on this. 1/6 times 2 over 2 plus 2 and 1/4 times 3 over 3, and then that gives us 2/12 plus 2 and 3/12. So now I can add those together, and I have 2, and then 2 plus 3 is 5/12. Obviously, if you have something like 10/24 or 15/36, that's fine, but it probably means that you did something else, and that's fine. All right, now we have 5/6 plus 1/3, so again, pause it to solve it. This one I'm almost going to do in my head. I know I can turn 1/3 into sixths, so that's 2/6. So this is 7/6, or it's 1 and 1/6. Oops. Or some equivalent. 1 and 1/6. So again, 1 whole is 6 over 6. We remove that, and that's 1 and 1/6. All right, 5/6 minus 1/3. All right, same thing, right? So I know this is 2/6. So this is 5/6 minus 2/6, which 5 minus 2 is 3/6, or 1/2. All right, next one, 1 and 1/5 minus 3/10. Okay, this one again, I kind of see that's 5 and 10. I know that 5 can become tenths, and that's going to be 2/10. So that's 1 and 2/10 minus 3/10. So here I'm going to use my handy-dandy number line. So if I start at 1 and 2/10, and I need to subtract 3/10, well, if I subtract 2/10, 1, 2, right, where am I? I'm at 1. How many more do I have to go back? I have to go back 1 more tenth to get to what? 9/10. Okay, so that's the answer, equals 9/10. Okay, number 2, 2A here. So this one we have to do equivalent fractions with common denominators. And the best one to do is the lowest common. That tells us we're thinking about stuff and not just blindly doing things. All right, 1/2 plus 1/3. So if I have my, right, here's 2 and 3. So I'm going to go 4, 6. I'm going to stop there because I know 6 as well. So I can get both into sixths. So I'm going to turn both of them into sixths. And my answer is going to have a sixth in it as well. So 1/2, that's 3/6. 1/3 is 2/6. So 3 plus 2 is 5/6. All right, 3 and 4/15 plus 2 and 1/3. Well, I'm not going to list anything out because I know thirds can get into 15ths. So I'm going to change that to 15ths. So I'm keeping this the same. 3 and 4/15 plus 2 and, so if I have thirds, and I want to get to 15ths, I'm going to be multiplying by 5 over 5. So that means it's 5/15. And I am adding, so this is 5 and 9/15. All right, next up, we have 3/5 minus 4/10. I look at that 5 and 10. I can't add, do anything. I can't subtract them yet. I have to change one or both. I'm just going to change one because I know fifths can go into tenths. So this is 6/10 minus 4/10. And if you want to see the math, how did I do that? If I have 3/5 and I'm wanting to get into tenths, I know I'm going to be multiplying by 2 over 2. So that makes 6/10. So 6/10 minus 4/10, that is 2/10. You might also have an answer like 1/5 because those are the same. And D, 10/16 minus 5/8. Again, I look at those denominators. They're not the same, so I do have to find a common denominator. I see the 8 can go to 16 by multiplying by 2, so I have to multiply by 5 by 2. So I have 10 sixteenths minus 10 sixteenths, and that's going to give us 0. So this is all about adding and subtracting, just a straight up adding and subtracting denominators with fractions with unlike denominators. This has mixed numbers and everything. So if this is something that you're struggling with, we'll have some IXL strands that you can be working on. It's just practice. You got to practice. You have until Thursday to try and figure this out. We'll have another review on Wednesday and go from there. Okay. Find the following, and we'll have a review on Tuesday too. So it's all good. 1/3 of 27. So we can think of this as if I have 3 groups of 27. How can I do that? 1, 2, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. So I have 3 groups of 9. That equals 27. So 1/3 of those is this. That's 20. That's 9. You could also think of it as 1/3 times 27, which is 27 divided by 3, which is 9. All right, so again, 1/12 times 60, so that can equal 60 over 12. This is one of those ones where you should be able to see that this is a number. Okay, so 60 over 12 is actually 5. So 5 is a way better answer than 60/12. Okay, sometimes having an improper fraction is okay, but when I can do the work, or if I can think about, my multiplication facts, then that's going to be important. All right, Mark drove 3/4 of a 36-kilometer trip before he stopped to get gas for his car. How many kilometers had he driven? So he's gone 3/4 of a 36-kilometer trip. I've been forgetting to tell you to pause. Remember to pause. Don't just follow along with me. It's going to make you think that you know what you're doing. So this can be 1/4 of 36, and we can do that 3 times. So again, 3/4, that's 3 1/4. So if I know 1/4 of 36 is 9, and then I multiply that by 3, that's going to get me 27 kilometers. Cool. Fill in the missing fraction or mixed number in each equation. So we should think this through. We should be able to think about this to understand. This is a really good number sense. So if you get these right, that's great. That means you have really good number sense when it comes to fractions. So I have 1 5/6, and I need to get the 2. Well, I would just need 1/6, right? We're at 5/6. 1 more 6 would get me to 2. Okay, something plus 5/8 equals 3/4. Well, if I think of this as 8s, so this is 6/8, that would just be 1/8 more. And here we have 3 1/4 minus something is 1. So if I start from 1 and I go to 3 1/4, well, that's 1, 2 1/4. So 3 1/4 minus 2 1/4 equals 1. All right, here we go. Ooh, our better buy. All right, which is a better buy? Explain your thinking using words, numbers, or sketches. So we have cans and money. So we have 4 cans for $3, or I shouldn't have made it that big. Cans, dollars. We have 8 cans for $6. I want to compare. I either need to get the 3 to a 6 or the 4 to an 8. I can do both by just multiplying by 2. 8, 6. So now I compare. I get 8 cans for $6. So they are the same. Not one of them is a better deal. All right, let's look at this one. 5 cans for $6. So we have cans, money, compared to 8 cans for $10. I either need to get these two to be common. I can get the 40. For this one to be common, I can get the 60. Why don't we get the 60? So to get the 60, I'm going to multiply by 10, which gets me to 60. And I have to multiply this one by 10, and that gets me to 50. So for 5 cans for $60, if I spent $60, I'd get 50 cans. So now we're going to multiply by 6 to get to 60. If you're going, Mr. Light, this is just like fractions, you're right. I get 48. So which one's the better deal? If I buy $60, I get 50 cans, $60, 48 cans. So 5 for 6 is better. Okay. All right. Sean made a mix of lettuce seeds to plant. The mix has 1/2 cup of green leaf seeds, 2 2/3 cups red leaf seeds, and 1 1/4 cups bronze. How many cups of seeds do we have? So we have 1/2 plus 2 2/3 plus 1 1/4. All right. So this one we got to really think about, and we have to break it apart. Okay. So first I'm going to add 1/2 to 1 1/4, and then I'm going to add that to 2 2/3. So if I have 1/2 plus 1 1/4, I know my half is 2/4, so this is now 1 3/4 plus 2 2/3. I know I can change these to 12ths, so that equals 1 what would that be? 9/12 plus 2 6. No, 6/12. No, that's not right. 6/12 is 1/2. This is where we start thinking about things, and you can notice things. So to get, I have to multiply by 4. So 8/12. So then this equals 3 17/12. But we wouldn't write that because we would know that there's a whole number in here somewhere. I would remove 12/12. So I get an extra 1 and then have 5/12 left. So 4 5/12 cups of seeds. Very cool. Abby is 5 1/2 feet tall. Craig is 5 1/3 feet tall. Who is taller? Well, 5 1/2 is more than 5 1/3, so Abby. How much taller? Well, let's see. So we have, they're both 5 feet, so now we're just saying Abby's 1/2 inch taller or Abby's 1/2 inch taller and Craig is 1/3. Oh, jeez. Abby's 5 1/2. Craig is 5 1/3. So this is 1/2 minus 1/3 because the 5s cancel each other out. Again, those denominators are not the same, so I do want to change those to, I would think, 6ths. So we're going to do 3/3 minus 2/2. So this is 3/6 minus 2/6, and that is 1/6 of an inch. Alrighty. Andrea worked out by walking and running on a park trail. She walked 2/5 of the trail and then ran 1/4 of the trail. How much of the work had she covered? So she did 2/5, and then she went 1/4 more. So again, looking at those denominators, I got to change them. Is there anything there? 4, 8, 12, 16, 20. No, it's just going to be 20, isn't it? Because that's 5, 10, 15, 20. Okay. So we have 2/5 times 4/4 plus 1/4 times 5/5. And that's going to be 8/20 plus 5/20, which is going to equal 13/20, okay, of the trail. Okay, did Andrea walk farther or run farther? Well, 2/5 is more than 1/4, so she walked farther. Is 2/5 more? Yeah. Right? Because 1/5 would be less, but 2/5. Oh wait, we did here to 20th. So yeah, then we can compare it. 2/5 is 8/20. 1/4 is 5/20. So yeah, 8/20. So walk farther. How much farther? So now we just take the work that we've already done, 8/20, and we subtract 5/20, and that would say 3/20 of the trail. Okay. David ran a 1/2 a mile down at the high school track and then walked 1/3 of a mile. How far did he go? Choose the best estimate. So this is 1/2 plus 1/3. More than a mile? Nah, because that would be a half plus something more than a half, and a third's not that. More than half mile but less than a whole mile? That makes sense. Less than a half mile? No, because he was a half and then he added more. So it would be this. How far did he go? All right, so we have 1/2 plus 1/3. So again, we're doing that to sixths. So that would be 3, 3. 2/2. So that equals 3/6 plus 2/6, which equals 5/6 of a mile. So that is more than a half, but less than a whole. When Sarah solved the problem, she got 2/5 of a mile for her answer. Is this reasonable or not? So she got 1/2 plus 1/3 equals 2/5. Is that reasonable? No! What'd she do? She added those denominators. We don't do that. And also, it's not reasonable because 2/5 is less than 1/2. So that can't be reasonable. So again, at this point, you should have a good understanding. What do you know? What do you don't know? What do you need to study to be prepared on Thursday? We're going to do some review work on Tuesday. We're going to do some more review work on Wednesday. So ask your questions, be prepared, study, study, study. Ciao.